Hello everybody and welcome to the section 4.3 lecture video. Once again, we're on page 22 in our chapter 4 note sheets. These can be found under the handouts section of my math lab. So what we're going to talk about today are rules of logarithms and using rules of logarithms. So some of these we've seen kind of before, but now we're going to more formalize them as we go through here. So basically what I have is I have all the rules here, and then I have an example for each one to show how it works. So okay. So the first one is log base a of a. So the idea behind a logarithm, remember, is that it's the exponent that you would put on the base, this number down here, to get the number inside the parentheses. So in this case, if I wanted to take a and put an exponent on to get a, that exponent would be 1. So something like the natural log of e, because remember the natural log has the base e, of e would be 1. Similar idea for the second one. What exponent do I put on a to get 1? Well, a to the 0 is 1, so log base a of 1 is 0. Okay, so log base 5 of 1 would be 0. So like these examples we've done, if I have the same base on my logarithm and an exponential on the inside, they basically just cancel each other out, because a to what power is a to the x? Well, the answer to that is x. So log, which is log base 10 of 10 to the 7th, would just be 7. And this also works if I put a logarithm in the exponent. These have the same base, so they cancel each other out. So this would be capital N. So 3 to the log base 3 of 4 would just be 4. Okay, so those are a lot of the rules and things we've already seen before. But beyond that, we have some other rules we want to work on. So if you have a product inside of a logarithm, you can rewrite that as the sum of two logarithms. So log base a of m times n is the same thing as log base a of m plus log base a of n. So log base 4 of 3x is the same thing as log base 4 of 3 plus log base 4 of x. So similarly, if I have a division inside of my logarithm, that would be the difference of two logarithms. Okay, so the natural log of 3/4 is the same thing as the natural log of 3 minus the natural log of 4. And this is a really good one to show that it works. So if I go into my class calc app here and do the natural log of 3 divided by 4, we see that that's negative 0.2876, so on. And then we can put in the natural log of 3 minus the natural log of 4, just to show that those are the same, right? So then we can see that in at least in this example, does work, and it does work in general. Okay. Now, the next one might actually be easiest to show you using some of our rules. So log of x to the third is the same thing, and I'm going to do some work over here on the side. So log of x to the third is the same thing as log of x times x times x. Now we could use the sum rule to rewrite this product as the sum of logs. So this would be log of x plus log of x plus log of x. And then if I add those three together, those are all like terms, so that's 3 log of x. So we see from the work we just did up here that log of x to the third is the same thing as 3 log of x. And so what you should notice is that that exponent just moved out in front. So in general, if I have log base a of m to the x, that would just be x times log base a of m. So we can bring exponents out in front of the terms. Okay, and then the last example here, if I look at the log base 2 of 1/3, so we just look at that one for a second. There's a couple different ways to think about this, but one way is to use the difference rule. So this would be the same thing as log base 2 of 1 minus log base 2 of 3. And then if you look at rule number 2 up there, log base 2 of 1 must be 0. So this would be 0 minus log base 2 of 3. And so that's the opposite of log base 2 of 3. So this is the opposite of log base 2 of 3. And so notice, if I take the reciprocal of the inside of a logarithm, I can just do the opposite of its reciprocal. So log base 2 of 1/3 is the same thing as negative log of 3. So log base a of 1 over n would be the same thing as the opposite of log base a of n. So what we want to be able to do with these is we want to be able to take logarithms and expand them out or contract them down. So take things that are single logarithms and expand them out so it's a bunch of simpler logarithms, or take a bunch of simpler logarithms and combine them back together into a single logarithm. And we're going to do that using these rules. So what we want to notice here before we move on is that if we ever have a number in front of a logarithm, if I want to put, or if I have an exponent, those go together. So if I have an exponent, I can simply move that out in front of the logarithm. Or if I have a number out in front, I can put it back in the exponent. Similarly, what we want to notice is if a term, a factor, goes in the numerator of our fraction, then the logarithm was positive. And if it goes in the denominator, then it's negative. So if I had, if I want to expand out a logarithm like log base 2 of xyz, that one's pretty easy because that's just using a single rule because I have a product on the inside. So that would just be log base 2 of x plus log base 2 of y plus log base 2 of z. So every factor from inside the logarithm gets its own logarithm, is how we have it expanded out. So then if I'm dealing with more complicated ones, what I want to look for are really two things. Well, really three things. First of all, what are all of the factors? So in this case, that would be 4a, 3, and b. So there's 4 factors, so I'm going to have 4 logarithms, right? In fact, I could go ahead and just write those. So I'm going to have a log of 4, a log of a log of 3, and a log of b. And then what you just need to determine is what is the coefficient on the front of each one of those logs. So if there's an exponent, we write that number out in front. So there's no exponents here, so these aren't going to have any numbers written in front of them. And then if it's in the numerator, it's positive, and if it's in the denominator, it's negative. So 4 and a are positive, so this would be log of 4 plus log of a, and then 3 and b are in the denominator, so they'll be negative. So minus log of 3 minus log of b, and that's all there is to that. Okay, so that's the idea. So if I look at this next one, what I should notice is there are 4 terms again, 4 factors again, 3x, a, and b. So this would be log of 3, log of x, log of a, and log of b. And now I need to decide what their coefficients are out in front and whether they're positive or negative. So 3 is in the numerator and it doesn't have an exponent, so it's just going to be positive log of 3. X is in the numerator and it's squared, so that's going to be plus 2 log of x. A is in the denominator, so that's going to make it negative, and it's raised to the 2/3 power, so that's going to be minus 2/3 log of a. And b is also in the denominator and also raised to the 2/3 power, so that's going to be minus 2/3 log of b. Notice that 3 did not have an exponent because on top we did not have parentheses, right? For 3 to be squared, it would have to look like this. It'd have to be 3x in parentheses squared like it is on the bottom. But because there are no parentheses, that's why that 2 only applies to the x term. Okay, so that's the idea. So go ahead and flip to the next page, pause the video for a second. Actually, before I have you try these on your own, let's go ahead and do the first one together because there's one more thing I need to remind you about. One thing to remember with this first one is, what do we do when we have roots? How do those apply with exponents? Well, the answer to that, remember, is that this is the same thing as log of 3x to the 1/2. Okay, and so like if we just look at the other ones down here that also have those fractional exponents, this one would be, if I put the square root on both, I'd have the natural log of x to the 1/2, and then the square root of 4 is 2. right? And then the last one, this would be the natural log of xy to the 1/3 power over t to the 4/3 power. Okay, so that's how you rewrite those using those radicals using exponents, which we didn't see on the previous page. So now you should be able to do all of these. So go ahead and pause the video, take a moment, try these 4 problems, and when you're ready, hit play, and we'll go through them. Okay. So the first one, there is no denominator, so everything's going to be positive. So this should be log of 3 plus 1/2 log of x, right? Because the two factors are 3 and x. X is to the 1/2 power, so that's why it gets a 1/2. Here we get log base 2 of 5, log base 2 of 2, and log base 2 of y. And log base 2 of 5 is in the numerator, so that's positive. 2 is in the denominator, so that's a -2. And the log base 2 of y, the y is also in the denominator, so that's also negative. And now we can actually simplify this further, because what's log base 2 of 2? Well, those have the same base, so that's just 1. Okay, the next one is the natural log of x and the natural log of 2. X is in the numerator and has an exponent of 1/2, so we put a positive 1/2 out in front. 2 is in the denominator, so we do minus the natural log of 2. And then for the last one, we have the natural log of x, the natural log of y, and the natural log of t. X is in the numerator to the 1/3 power, so 1/3 x, natural log of x, plus 1/3 natural log of y, minus 4/3 natural log of t. Okay, and so that's the idea of how to expand out logarithms. Now we can also take this the other direction and combine logarithms together using these rules. So when you do this, the thing to keep in mind is exactly the same things that we did before. We're going to have a single logarithm. So this one's going to be log base 7. And any term, any log that's positive, the inside of that logarithm goes in the numerator, and any one that's negative goes in the denominator. And if we have a number out, a coefficient out in front, that becomes the exponent. So in this case, x to the 5th is in a positive logarithm, so it goes on top. X squared is in a negative logarithm, so it goes on the bottom. And then there's a 4 out in front, so this has to be raised to the 4th power. And now, if we want, we can just simplify that a little. So this is log base 7 of x to the 5th over x to the 8th. And then we can cancel out 5 x's, so this is log base 7 of 1 over x to the 3rd. Okay, so that's the idea. So in this case, we're going to have a natural log. And anything that's positive goes on top and is multiplied together. So we 2, 3, and 5 are all on top, multiplied together. And the 7 is a negative logarithm, so that goes on the bottom. And then we multiply on top, and we get natural log of 30 over 7. Okay, and then the last one here, same thing. So we've got the log. X and y are positive, so they're going to go in the numerator. Z is a negative log, so that's going to go on the bottom. And then we've got this 1/2 power. And both, notice that there's brackets around log x and y, which means both of them are raised to the 1/2 power. So we can write it like that. Or if we wanted to, we could use radicals instead of exponents and do the square root of xy over z. Okay, so that's the idea. So we're just working backwards using the same rules we used to expand out. So go ahead and flip to the next page, pause the video for a moment, and give these a try. Okay, now that all of you have had a chance to try these, let's go through them together. So the first one, we've got a log base 2. The 5 is positive, so it goes in the numerator. Nothing's negative, so there is no denominator. X is in the numerator. So we get a positive x, and then we've got this 3, so it's going to be x to the 3rd power. Okay, so that's the idea. So the second one, we've got log. We've got positive and negative log, so there is going to be stuff in the denominator here. So x and z are positive, so they'll go in the numerator. Y and w are negative, so they'll go in the denominator. And then we've got a 1/2 in front of x, so x will be to the 1/2 power. And we've got a 1/3 in front of w, so w will be to the 1/3 power. So like that. And then the last one, we've got log of 4. And then we've got x squared is in a positive log, so it'll go on top. X to the negative third is in a negative logarithm, so it'll go in the bottom. And x is has a positive log, so it'll go on the top. And then we need to raise these to some exponents. So x squared has a 3 out in front, so to the third power. X has a 2 out in front, so to the second power. And log base 4 has a 4 out in the x to the negative third has a 4 out in front, so we'll put that in the exponent. And then we're just going to need to simplify here. So this would be log base 4 of x to the 6th times x squared over x to the negative 12th, which is log base 4 of x to the 8th over x to the negative 12th. And then you subtract 8 minus negative 12, so that's x to the 20th. Okay, so that's the idea. So that's how you use these rules to combine them back together. So the big takeaways here are if you have an exponent inside of the logarithm, then when you expand it out, it goes out in front. If you have an exponent in front of a logarithm and you're combining it back together, then it goes up in the exponent. Those two go together. And then positive logarithms are associated with being on top, and negative logarithms are associated with being on the bottom. So that's really all there is for rules of logarithms. So then the last thing, we're actually going to end up skipping page 28. The last thing we're going to talk about in this section is just a little bit more practice with solving logarithmic equations. And this really doesn't, what we want to teach today is another way to solve these that is similar to what we did last time, but not quite the same. So one of the ways to solve a problem that looks like 3 to the x equals 12 is to use the definition of logarithm, which, remember, the definition of logarithm is that if log base a of y equals log base a of x, if and only if a to the y equals x. So we can move between these two by taking the base and moving it to the other side and changing what type of function it is. So like, for example, in this first case, I can move the 3 to the other side and make it the base of a logarithm. Okay, so that's one way to solve that. And then we'd put that in the calculator. Another way to solve this is to use the one-to-one property of logarithms. So we know that log base a of x sub 1 equals log base a of x sub 2, then x sub 1 equals x sub 2. Well, this actually works the other way as well. So another way I could solve this is by taking the natural log of both sides and then using my exponent rule. So my exponent rule says I can bring this exponent out in front. Right, so this x can come out here in front. So this would be x times the natural log of 3 equals the natural log of 12. And then we can divide both sides by the natural log of 3. And so this ends up being x equals the natural log of 12 divided by the natural log of 3. And what we can see is in both these examples, we get the same answer. So if I go into my calculator and I do log base 3 of 12, I get 2.2619. And if I do the natural log of 12 divided by the natural log of 3, I get the same answer, 2.2619. So x would be approximately 2.2619 in this case. And notice in this example over here, I use the natural log. I like to use the natural log because it does not look like any of the other logarithms. Sometimes when we use the common log, it can get confused for some of these other logarithms. But yeah, you could use any logarithm you want because it just uses log base a, so the general log, to do this example. But either of those methods is fine. We talked about how to do this first method last time when we talked about the definition of a logarithm, which is why I'm focusing on this version here, but you can use either one of them. So let's go ahead and try another one using this second method over here. So this would be the natural log of 1.09 to the x equals the natural log of 3. Then we bring the x out in front, so that would be the natural log of 1.09 equals the natural log of 3, and then divide by the natural log of 1.09. So x equals the natural log of 3 divided by the natural log of 1.09, which we can then put in the calculator to get an approximation. So the natural log of 3 divided by the natural log of 1.09. Oops, sorry. 1.09, which is 12.7482. Approximately. Okay, so at this point, go ahead and pause the video for a second and try these last two. Okay, so now that you've tried them, let's go ahead and go through them together. So I can take the natural log of both sides, then bring the x out in front, so using the exponent rule, and then divide by the natural log of 2. So x equals the natural log of 9 divided by the natural log of 2. So 3.1699 approximately. And then the last one, take the natural log of both sides, so same idea. Then bring the variable out in front. And then divide to get the variable by itself. So x equals the natural log of 0.25 over the natural log of 0.62. And then we can go in our calculator and get an approximate solution. So that one's 2.899998, so that's going to round up to approximately 2.9000. Okay, and that's it for section 4.3. So don't forget to do your homework and the quiz for this week. And if you have any questions, feel free to email, call, text, or you can visit my office hours, which are on Tuesdays, Thursdays, and Sundays, and you can check your email for the links to get to those virtual office hours.